everybody. This is Stephen again with Service Plus. I have David with the electrician Ed here again with us for our weekly installment. And today we're going to talk about breakers and fuses. What do they do? Why are they important? And why do you care? So to get that started off, the National Electric Code calls breakers and fuses overcurrent protection, which most homeowners probably haven't heard, but could you explain to us what that means, overcurrent protection?
Okay, so overcurrent protection is, well, let's talk about an overcurrent. Overcurrent is kind of like an umbrella term that covers overloads, ground fault, and short circuits. But normally when I think of an overcurrent, I'm thinking of something that happens very rapidly, like in a short circuit. But technically an overload is also one. So what is an overload? An overload is where you've got too many things plugged in to a circuit, and someone plugs in the last thing. And what's happening is whenever current goes through a conductor, it causes an elevation in temperature. And the more amps you have running through a circuit, the hotter it's going to run. And so an overload is basically it's kind of like a slow heating up until it's gone over the threshold, and then there's a bimetallic strip inside that breaker that begins to flex because one side is a different kind of metal than the other, so it stretches the other one away and it breaks the circuit that way. There's some little connections in there that come apart, some contacts that break.
And when you say amps, you're saying that's basically the flow of electricity. So somebody has plugged in too many things, turned them on. Now there's too much electricity flowing on that conductor or wire that's running that circuit.
Right. Amps is short for amperes, which is a measurement of how many electrons are flowing through the circuit at any given 1 second. So if you have a 20 amp breaker, there shouldn't be any more than 20 amps going through that circuit. And if it gets beyond that, then it will trip. You don't want to keep your breaker maxed out like that at all times. But if you are running 16 amps, then that's kind of a good thing for if you're going to do it all the time, if you're going to run something all the time.
Mm-hmm. And so we mentioned that there's too much electricity flowing on the wire. So the wire and the equipment that you're plugging in, that's what decides the size of the breaker or the size of the fuse. Could you explain that a little bit?
Yeah. The purpose of the OCPD, or the overcurrent protective device, which could be a breaker or a fuse, is to protect the circuit, which would be the wires and the insulation around them. And the second fold of that twofold purpose is to protect equipment. So sizing comes into play there. The larger the conductor, the more it can handle, and the more amps can go through it. The other part of that is the insulation around that. It's made out of a thermoplastic usually. In almost everything that we see in a house, it's going to be thermoplastic insulation, which will actually melt off at a lower temperature than the copper will ever melt.
Mm-hmm.
So when we're talking about protecting the wires, we're really talking about protecting that insulation. And there's different types of thermoplastic insulation, and they're rated for different things. So as electricians, we have to pay attention to ratings, very important. And it all boils down to heat.
Right.
almost, uh, no pun intended there with the boiling. Uh, but everything comes back down to heat. So, and it could be any kind of heat. It could be the temperature in your attic where your circuits are going through. That's going to add up.
Mm-hmm.
And during summer, in a hotter time of the year, if you've got your circuits running through an area that's getting hotter than usual, and then you're plugging more things in, you're probably going to see more times your breaker is going to trip.
Mm-hmm.
And that could indicate it's just a really hot day, and you're not doing anything different than usual. It doesn't necessarily mean your breaker's wearing out,
Mm-hmm.
uh, but you may need to cut back on some of the things that are plugged into that circuit. Maybe try plugging it into a different circuit.
So there's a couple things I'd like to mention on that. And that's one thing when we get calls that someone has tripped their breaker, oftentimes they will think that the breaker has a problem, which of course sometimes it does, but almost by far the majority of the cases, the breaker is actually supposed to have tripped because, like you mentioned, that wire, that conductor has heated too much to where that insulation is now in danger of being potentially melted. And then the other issue that we see quite a bit with the people that have the screw-in fuses, actually did bring a couple here.
Okay.
So a lot of people have seen these screw-in fuses. They're pretty common in really old houses. And the problem with these is when someone does blow the fuse, it has a little strip in here, like David mentioned, and when it gets over that current rating, it burns that strip to where it no longer makes a connection and it cuts the power off.
Yeah.
And so what we see is the fuse was probably the proper rating when installed by the electrician, whatever point that was. So for example, 14 gauge wire is a very small wire that's very common for inside homes, and that should be on a 15 amp fuse or a 15 amp breaker. And we see when someone blows that 15 amp fuse, they typically are frustrated that the power's off and they will grab whatever fuse happens to be nearest, screw it back in. And now, for example, the one I'm holding here happens to be a 25 amp, which it's probably backwards in the camera, but
Looks
so
good to us.
okay, so they probably will grab that if it's sitting there just to get the power back on. But now, whatever reason caused that fuse to blow initially, now it's not going to blow and that wire is going to continue getting hotter and hotter.
Yeah.
So could you explain, speaking of the heat, the different types of overcurrent and what does that mean to the homeowner? So there's different types of things that can blow the fuse. We mentioned plugging in too many things, but what else can be involved in that?
Okay. Okay, on the overload where you've got that warming, you could be plugging too many things in. You could be having an equipment failure. Let's say that it's an attic fan or something like that that's causing a breaker to trip. It could be a bearing is getting going out on your fan, and that causes more resistance, which causes the current to have to go up in order to keep doing the same. See, a motor is just it's gonna sacrifice itself. It will do everything it can to do its job. If you give it low voltage, it's still gonna do its job, but it will. There's always a balancing act between voltage and amperage. If you've got low voltage, the current has to go up in order to maintain the same wattage, the same amount of power output, and so that could be another thing that's tripping your breaker. It may not be your breaker itself. It could be something like that. This wouldn't apply to a home, but let's say somebody threw a bunch of wheat onto a belt and it was just too much. It overloaded the belt, and so it ended up overloading the circuit. That's the same. the same kind of thing. Okay, besides overload, we talked about ground fault, and that should be that almost is in a different class by itself, I would say, because it may not be enough to ever blow a fuse or trip a breaker. What we want, and I think we talked about this last week, I'm not sure exactly what ended up on the video, but we talked about how that third wire in your receptacle is for the grounding, is for grounding equipment. And it's supposed to be like this emergency path, never gets used except in case of a ground, of a short circuit or something like that goes wrong, and it runs back on that grounding path really fast, and you've got way more current going through it than what your breaker or your fuse would be able to handle. And so the overcurrent protection device opens. Your fuse opens the circuit and clears the fault that way, or your fuse blows. And it's just done its job, And
Right.
so if your breaker's tripping, it's not necessarily just a nuisance. It could be a real serious thing.
Yeah, you could celebrate when it trips.
Yeah.
Honestly, because you didn't have a much worse problem.
Yeah, possibly.
Oftentimes the worst problems that we encounter is when the breaker doesn't trip. And because, older connections may heat up, or, equipment may heat up, and those are things that are in the house around where people are working and playing, whatever they're doing in their home, cooking. And, we want the issue to happen at the fuse box or the breaker box, right?
Right.
To open that circuit. So go ahead.
I was just going to mention that kind of brings us to that point you and I talked earlier about how long things should last. Everything's got a lifespan. Can't expect anything to last forever, and that includes your electrical equipment, your breakers. Hopefully your wiring is going to last a long time, as long as you treat
Wait a second. Hold up. I thought that fuse boxes and old Federal Pacific breaker boxes were good for like 80 years. That's not true?
I think I I can tell you for sure that Federal Pacific is not good for that long. It wasn't that long. They went out of business because they burned down too many houses, right?
Right.
And I think you found some information that said that they were really only rated for 30 years, and if you've got a Federal Pacific breaker in your house, that's unless it's got the white numbers on it, which is still being manufactured that way specifically to replace the old red Federal Pacific breakers. So if you've got those are okay. They're expensive, and it might behoove you, if you've got a whole panel full of Federal Pacific breakers, those are the ones with the red or orange looking tabs on the numbers. You might want to replace the entire panel. It may end up being cheaper.
And I will say, though, as I mentioned that earlier, but fuses, and I brought a different type of fuse as well. This is a cartridge fuse. I do tell people that fuses themselves are pretty reliable, like we did mention earlier as well. So just because you have an old fuse box, the fuses are probably still good. They maybe have had issues from overheating where they touch the metal, but other than that, the fuse is pretty good. What really people have to worry about with having an old fuse box, I think, is the bus bar and basically the internal parts of the fuse box itself, because it's so old. Speaking of the lifespan, one last thing we can touch on is we know that there's a current rating for what that breaker or that fuse is trying to protect the conductor or the equipment with. There are some other ratings that the breakers have that people aren't so familiar with. You know, we're always talking about a 15 amp breaker, 20 amp breaker, so on and so forth. But there are other ratings that apply to these. Can you talk on that a little bit?
Yeah, I'm glad you brought that up, Stephen. Yeah, those all of the ratings are they're kind of connected together, and it has to do with the environmental um, the environment that the breaker is going to be operating in a lot of times. Remember, we talked about ambient temperature. That's one of them. So in the rating of your breaker, it's going to include that it's within a certain ambient temperature. So the operating um, environment, the ambient temperature. Also, you've got a rated voltage that goes along with the breaker as well. And then of course, we've already talked about your rated current that should be able to go through it. There's also another rating on most breakers. And that if you look at a breaker, you'll see usually it'll say 10,000 AIC.
Mm-hmm.
And what that means, that AIC is what is the maximum that this breaker will still safely open, how many amps it can actually still handle. So it stands for ampere interrupting current,
Mm-hmm.
I believe. And that is in the case of a short circuit, because it really depends on how much at any given point in the system where your breaker is installed, how much potential energy you have right there.
Mm-hmm.
And short circuit is available, the current that's available right there. The further and the deeper you get into your house or into your structure, the longer the wires have become. Maybe they're a lot smaller now than where they first were when they came in at the at your panel, and that creates a lot of resistance, and that's actually safer for you than having great big larger wires than what you have to put at. So as electricians, uh, we're
What's the
always trying
name
to.
of that rating? What's the
That's
name of that?
AIC.
And so that's, something I haven't thought of before. It just came to me now is that's probably another factor that should be considered with an older breaker box is, now the power lines, we're using so much more power now that the power company has probably a much, much greater available fault current.
Mm-hmm.
And if you think of it in, a lot of people like to think of electricity in terms of like water as an analogy. And so if you're thinking that the breaker's shutting off the water valve, um, the fault current, this is where the analogy falls apart in many places, but if you had a whole waterfall trying to go through the valve, something's going to break. And
Mm-hmm.
that's essentially what we're talking about. So if it's no longer going to do its function because it has so much current that it's going to melt the internals essentially.
Yeah. And to be honest, I'm not sure what the typical household available short circuit would be, like right there at their equipment. Your utility company should be able to tell you what that, they can do that calculation, they can tell you what it is. And then your electrician, if he's really good, now I don't know, or you can get an electrical engineer, he should be able to figure this out, where
Yeah.
you're, but for most things, your typical breaker is going to be rated at 10,000. If it doesn't say anything on that AIC, if it doesn't have an AIC rating on it, then it is just automatically, it's only 5,000 amps.
Mm-hmm.
Plenty. Who knows? It really depends on the situation, the placement that breaker is in, and what
And
it's being.
there's so many power companies here in Kansas that it's probably all over the place from one to the next, as far as the available current.
think I missed that last bit that you said. It kind of froze.
Yeah, I was just saying there's so many different power companies around here that it probably has a pretty good range on what that available fault current is from one to the next.
Yeah, and it depends on, how if you've got a 200 amp service on your home, or if you've got a 60 amp service on your older home, you're going to have a lot lower.
And so just to recap from the homeowner's perspective, everything we covered here is the breakers and fuses. If the fuse blows, if the breaker trips, that's not a bad thing usually. It can be on seldom occasions, but if you have that opportunity, you know that you're avoiding a potentially dangerous situation that could be corrected before that's reset. And then those things are size based off the size of the wire. And then once again, that's all to protect from overheating of the conductors and the danger to the insulation of the wire. Is there anything else you want to touch on to the homeowner that's sitting there still listening to us?
Yeah, I would say I do want to mention some things that can cause premature failure of your equipment. Um, well, number one is heat, and it can be caused by a loose connection somewhere. If you've got a breaker that keeps tripping and you have to go reset it, check and see if you've got too many things plugged in. Try switching some things around. And if it still keeps happening, your breaker could have gone bad, but there could be a loose connection somewhere. And sometimes we find that right in the panel itself, right in the breaker panel. The lug didn't get tightened down well enough on the breaker. And if you ever see sparks where you don't think there should be sparks, that might be another reason to call your electrician. But a loose connection is really dangerous. If you see flickering lights, there could be a loose connection there. It could be down in the switch. That's anything that's intermittent. I would worry a little bit more about that, because I don't want to see that turn into just a building up of more and more heat.
Mm-hmm. And so, long story short, if your breaker trips, do your check, your little walkthrough, and if you think you've solved something, you can reset it. Probably shouldn't reset it more than 1 or 2 times without investigating what's causing the problem further.
Sure.
And so I think we stayed on topic better this time. That was fun. And if anybody has any more questions on that or needs some more elaboration, just let us know in the comments. And thanks, David. And we'll see you again next week.
All right. Thank you, Steven.